Yeah, so we are continuing with the factorization. All right. So here we'll have to divide x squared plus 7x plus 10 by x plus 5. All right. So this is what we have to do. X squared plus 7x plus 10 divided by x plus 5. Now the numerator you can see is a quadratic expression. So you'll have to factorize that by splitting the middle term. So the sum is 7, product is 10. So the two numbers are 5 and 2. Because 5 plus 2 is 7 and 5 into 2 is 10. The numbers, to find the numbers, you know the method. You can take 10 and find its prime factors. 2 5s are 10, 5 1s are. So 10 is equal to 2 into 5. So using this, you can find the numbers. Okay. So 2 and 5 and 2 or 2 and 5 are the numbers that satisfy the sum and the product. Sum 7 and product 10. Now split the middle term. X squared plus 7x should be written as 5x plus 2x or 2x plus 5x plus 10 divided by x plus y as it is. Now group the first two terms, group the last two terms. So between the first two terms, the first and the second term, x is common. So x plus 5 in the bracket, because x into x is x squared, the first term, and x into plus 5 is plus 5x, the second term. Now 2 is common between the third and the fourth term. 2 is common between the third and the fourth term, or the HCF of the third and the fourth term is 2. So plus 2. I've told you, write the sign as it is. Plus as it is. The HCF of this term and this term is 2. That becomes the common factor. Now 2 into what will give you the third term? 2x. So 2 into x. 2 into x is the third term, 2x. Plus 2 into x is plus 2x. And plus 2 into plus 5 is plus 10. Divided by the denominator as it is, x plus 5. Now don't be in a hurry to cancel x plus 5 and x plus 5. You cannot cancel it like this. You cannot cancel like this because there's a plus sign in the middle. There's a plus sign here. You cannot see, like supposing you have 4 plus 5 by 4. You cannot cancel 4 and 4. But if it is 4 into 5 by 4, when it's a product, then you can cancel out 4 and 4. So here in the numerator, you can see it is x into x plus 5 plus 2 into x plus 5. So it's addition of two terms or two expressions in the numerator, like 4 plus 5. So you cannot cancel x plus 5 and x plus 5. Next step, whatever is common in the brackets, write out that once, x plus 5, and gather the remaining terms, x plus 2 in another bracket. Then divided by x plus 5. Now you can see it's a product. The numerator is a product, x plus 5 into x plus 2. Now you can cancel this x plus 5 and x plus 5. So the quotient on division is x plus 2. That is when you divide this expression by this expression, the quotient is x plus 2. Like when you divide 10 by 5, what is the quotient? 2. Or when you divide 21 by 3, the quotient is 7. In the same way, when you divide this expression by this expression, the quotient is x plus 2. So we here divide by factorizing. We factorize the numerator. We are not doing the long division. We are factorizing the numerator to find the quotient. See, what is the result of division? Divide the following. So what should be the answer? The quotient should be the answer. So we are finding the quotient not by performing the long division. You can also perform the long division. I'll do that for you now. You can also perform the long division to get this quotient. So here we are factorizing the numerator. We are factorizing the numerator to find the quotient. Please take down this. Next, I'll also perform the long division and show you how you can obtain the quotient. Take down this, children. Done, children? Finish writing, online students?
Yes, ma'am.
Okay. Now let's perform the long division. Okay. We have understood the long division procedure, some time back in one of the classes. Okay. Let's just recall that. Maybe the second one where we do the long division, you will be able to, help me. So I'll help you recall now. So you need to divide the first term of the dividend by the first term of the divisor. That's how you get started. That's how you get started. Divide the first term of the dividend by the first term of the divisor in the rough column. So x squared by x. What do you get? X. That will be the first term in the quotient. That will be the first term in the quotient. Now you need to multiply x with x and multiply x with plus 5. And write the results here under the dividend. X into x is x squared and x into plus 5 is plus 5x. All right. So divide x squared by x. We get x. That's the first term in the quotient. Now multiply x. It's like this. You should multiply x with x plus 5. You must multiply x with x plus 5. So what do you get? X into x is x squared. And x into plus 5 is plus 5x. This you must write under the dividend. Change the signs because division always means subtraction. So change the signs. X squared plus x squared minus x squared gets cancelled. 7x minus 5x is 2x. and this plus 10 comes down. Plus 10 comes down. So now we'll have to find the second term in the quotient, for which we have to again divide 2x by x. This one is called the new dividend. This is the new dividend. This is the dividend given in the question. Now this one, this remainder is the new dividend. So the first term of the new dividend is 2x. The remainder becomes the new dividend. The first term of the new dividend is 2x. So divide that by the first term of the divisor, as you did here. As you did here. So we need to divide 2x by x, which gives us 2, because x and x will get cancelled, so you get 2. 2 meaning plus 2. So that's the second term in the quotient. That's the second term in the quotient. Now multiply 2 with the divisor. We need to always multiply the divisor. Whatever term you write in the quotient, you should multiply that with the divisor and write the terms under the dividend or the new dividend. So 2 into x is 2x and 2 into plus 5 is plus 10. Now write this under the new dividend, 2x plus 10. Change the signs. Change the signs. 2x minus 2x, 0. 10 minus 10, 0. And what's the quotient? X plus 2. And that's what we got here by factorizing. Here we factorized to find the quotient. Here we have performed the long division to find the quotient. Okay, so we are learning how to, so in this method, we are learning how to factorize the numerator and find the quotient. Understand, children? Yeah, take down this also. This is not a part of the answer. This is not a part of the answer. This is just for you to understand that it is the same we get through long division. You can just demark it like this, put a line like this, and then you can just write something like not a part of the answer. This is the long division procedure. Yeah, take it down, children.
Done, ma'am.
Yeah. Okay. Next question. I'll just change the heading for you. I'll just say factorize and divide so that you understand when to do this procedure. Factorize and divide. Please change the heading, factorize and divide. Which clearly means you'll have to factorize the expressions wherever possible and perform the division and find the quotient. And it's not long division. You need to factorize the expressions wherever possible and divide. And the result of division is the quotient. The second one under the same heading. The second one under the same heading. 2x squared plus 13x plus 20 divided by x plus 4. Which means 2x squared plus 13x. You don't have to put the brackets. It may be given in the question, but you can just remove it. 2x squared plus 13x plus 20 divided by x plus 4. This is what we have to find. All right. So again, the numerator is quadratic. So you'll have to factorize by splitting the middle term. The sum is plus 13. And the product is 2 into 20. 2 into 20. See this one. This 2 into plus 20 is the product, which is 40. The sum is the coefficient of x, which is plus 13. Plus 13. Now, if it is not easy to guess the two numbers, you can perform the, you can find the factors of 40. So 2 20 times, 2 10 times, 2 5s are 5 1s are. So 40 can be expressed as 2 into 2 into 2 into 5. Now use these numbers and find two numbers that satisfy the sum and the product. So you can see here 8 and 5. Because 8 plus 5 is 13 and 8 into 5 is 40. So the required numbers, the two numbers that will satisfy the sum and the product are 8 and 5. 8 plus 5 is 13. 8 into 5 is 40. So split the middle term. Write the first term as it is. Write the last term as it is. Split the middle term. The middle term plus 13x is written as plus 8x plus 5x. Because the numbers are plus 8 and plus 5. Signs you have to fix. You can take any signs. You need to get the required sum in the product. The sum is plus 13, positive 13, and the product is positive 40. So the two numbers are plus 8 and plus 5. Write the first term as it is, write the last term as it is. Split the middle term. Don't write plus 13x. Instead, write plus 8x plus 5x. X plus 4. Now, group the first two terms. 2x squared plus 8x. So what's the HCF of 2x squared and 8x? What's the HCF of 2 and 8?
2, ma'am.
2. What's the HCF of x squared and x? The least power.
X.
X, the least power. Okay, so now 2x into what will give you the first term 2x squared?
X.
X. Now 2x into what will give you the second term plus 8x?
4.
Plus 4.
4.
Yeah. Now after 8x, what is the sign? Plus. Put that as it is. 2x squared plus 8x. We are done till there. Now after that, the sign is plus. Put the sign down as it is. Now what's common between 5x and 20? Or what is the HCF of 5x and 20?
5.
5. 5 into what is the third term 5x?
X.
Very good. And 5 into what is the fourth term plus 20?
Plus 4.
Plus 4. Very good. Divided by x plus 4. So as I told you, don't be in a hurry to cancel x plus 4 and x plus 4 because it's addition. It is this expression plus this expression. So you cannot cancel here. So now write the common expression once in the bracket x plus 4 and gather the remaining terms. 2x plus 5 in another bracket. Divided by x plus 4. Now it's a product. You can cancel. So the quotient is 2x plus 5. Please take down, children. Also perform the long division. I'm not doing it. Complete this answer. Also perform the long division. I'll just be back in 5 minutes, children. Please do this. Yeah, completed the long division, children. Online students, finish the long division.
Yes, ma'am.
Okay. So the dividend is 2x squared plus 13x plus 20. And the divisor is x plus 4. So what's the first term in the quotient? What's the first term in the quotient? 2x, right?
Yes, ma'am.
2x into x is 2x squared. You need to multiply now 2x with x plus 4. 2x into x is 2x squared and 2x plus 4 is plus 8x. Change the signs. Change the signs. Cancels. 13x minus 8x is 5x. 13x minus 8x is 5x plus 20. Plus 20. Correct? Now the next term. To find the second term in the quotient, we need to divide 5x by x. 5. So plus 5 is the second term in the quotient. Now we need to multiply 5 with x plus 4. 5 into x is 5x plus 5 into 4, 20. So 5x plus 20. Change the signs. 0. So that's what we got here also. 2x plus 5. So now the question is when to use which method. If nothing is specified, it will be actually specified. It will be specified, but in a case where it is not specified, you can use any method. But mostly the question will be factorize and divide. In that case, you have to use this method. This is the approach. Factorize and divide, this is the approach. If at all nothing is mentioned, then you can use a long division. Okay. Next one. Under the same heading, children. So here in the numerator, we don't have any quadratic expression like what we had earlier. 5pq cannot be factorized. 5pq is 5 into p into q. It's already very simple. It cannot be factorized any further. P square minus q square is of the form a square minus b square, which can be written as a plus b into a minus b. So p square minus q square can be written as p plus q into p minus q. Because what's the identity? A square minus b square is a plus b into a minus b. Then p square minus q square will be p square minus q square will be p plus q into p minus q. So factorize p square minus q square as p plus q into p minus q divided by 2p into p plus q. Now you see in the numerator and in the denominator, it's a product everywhere. It's 5 into p into q into p plus q into p minus q. It's a product. The denominator already is a product, 2 into p plus q. So now you can simplify, meaning you can cancel p plus q, p plus q. In the numerator and denominator gets cancelled. P and p here cancels. So we are left with 5 into, okay, I forgot the cube, 5 cube, correct? So we have 5q in brackets, p minus q, and in the denominator we have a 2. If this were 6, you could have cancelled. If instead of 5 it was 6, then 2 1s are 2 3s are. But no, it's 5. So the result is 5q into p minus q by 2. Take down, children. Done, children? Finished, online students?
Just a second, ma'am. I'm almost done.
Okay. That's time.
Done, ma'am.
Yeah. Next one. Or not plus, divide, division plus. Divided by. So the rule is in an expression, whenever there's something common, we need to first bring out the common factor. Right, 39y square as it is into, you can see this expression 50y square minus 98. In an expression, whenever there is something common, now this expression has two terms, 50y square and 98. Now 2 is common to both these terms, or 2 is a HCF of these two terms. So bring out that common factor. Take out 2. So in the bracket, you would have 25y square minus 49. See, 39y square as it is. See, that is a single term. 39y square is a single term. What will you do with that? Write that as it is. In the bracket, you have an expression 50y square minus 98. 50 and 98 have 2 in common. Bring it out. So then in the bracket, we'll have 25y square minus 49 divided by 26y square into 5y plus 7. Now cancel. Y square, y square. In the numerator and denominator gets cancelled. See, it's a product everywhere. See, you cannot cancel this. You cannot cancel 7 ones are 7, 7, 7 the 49. Why? Because there's minus here. It's 25 y square minus 49. So between two terms, if there is a plus or a minus sign, you cannot cancel them with anything else. Now 25 y square and 49, between them there's a minus sign. So neither 25 y square nor 49 can be simplified with any other term. You can cancel this as a whole, you can cancel 25 y square minus 49 as a whole, you can cancel with, if at all there's the same expression in the denominator. But you cannot cancel 7 ones are 7 sevens are like this. Okay. So y square and y square. See, it's a product. 39 into y square into 2. It's a product. And here also 26 into y square. So you can cancel y square and y square. 2 ones are 2 13 times. 13 ones are 13 threes are 39. Okay, so in the numerator we have 3 and in the bracket we have 25 y square minus 49, both of which are perfect squares. 25 y square is a perfect square. 49 is also a perfect square. Open and close square brackets like this. And in the square brackets, since both the terms are perfect squares, just show empty brackets and raise it to the power 2. Writing the same thing again. Write the leftover in the numerator. 3, that's it. 3 remains in the numerator. Open and close a bracket. Sorry, a square bracket. Within that, something the whole square minus something the whole square divided by 5y plus 7. So 25y square. 25 is 5 square. Y square is y the whole square. And 49 is 7 squared. Now the numerator is of the form a square minus b square, which can be written as a plus b into a minus b. 5y the whole square minus 7 the whole square. A square minus b square, which can be written as a plus b. What is a plus b? How do you write a plus b?
I plus 7.
5y.
5y plus.
Yeah, a plus b into a minus b.
5y minus.
5y minus 7. Very good. Divided by 5y plus 7. Now 5y plus 7, 5y plus 7. As an expression, they get cancelled. As a whole, I'll just write the final answer here. So the answer is 3 into 5y minus 7. This is the final answer. This is the result on division. 3 into 5y minus 7. All right, children. So the expressions which have to be factorized in the numerator can be of the form a square minus b square, which should be factorized as a plus b into a minus b. Or the expression in the numerator can be a quadratic one, which has to be factorized by splitting the middle term. So we have encountered these two situations so far. We'll do a few others and then I'll tell you what else is possible. So far what we have seen is the expression in the numerator can be factorized using the identity a squared minus b squared, which is a plus b into a minus b. Or the expression in the numerator is quadratic, which has to be factorized by splitting the middle term. Yeah. Yes, children, please write on this. So here, children, in the numerator, we have an expression which is not quadratic. Okay, so if it's quadratic, we can split it, we can factorize it by splitting the middle term. It's not quadratic. Now, when you look at that, there are three terms and x square is common to all the three terms. Remember that whenever we have to factorize, the golden rule is to take out the common factor first. Sometimes if you don't take out the common factor, you cannot factorize it at all. That should be the first step. That is, now this expression has three terms. Now these three terms have something in common. Bring out that common factor. See, after bringing out the common factor, also maybe we have to further factorize it. So that we'll know only when you bring out the common factor first. So do that as the first step. So 44 as it is, I've told you that the least power will be the HCF. All right. So x to the power 4, x cubed, x squared. The least power is x squared. That's the HCF. Bring it out. Between the numbers, the HCF is 1. Between the numbers, the HCF is 1. Between the literals, x to the power 4, x cubed and x squared, 2 is the smallest power. So x squared is the HCF. So now x squared into x squared is x to the power 4 minus, tell me the second term, x squared into what will give us minus 5x cubed.
Ma'am, minus 5x.
Minus 5x, very good, minus 5x. And then x squared into what will give you minus 24x squared.
Ma'am, minus 24.
Minus 24 divided by 11x into x minus 8. Now you can simplify 11 ones are 11 fours are x here, and this is x squared, which is x into x. So x squared of the two x's, one x is cancelled to the other x. Now you can see that in the bracket, we have three terms and it's a quadratic expression. Now this should be further factorized by splitting the middle term. And you were able to, like reveal this or find out about this, quadratic expression only because you took out x squared as the common factor. If you did not bring out x squared, then you will not know how to factorize the expression at all. This expression, you first brought out the common factor x squared. Only when you do that, you are able to see this quadratic expression, which can be further factorized by splitting the middle term. Okay. So now this quadratic expression x squared minus 5x minus 24, the sum is minus 5, the product is minus 24. Can you guess the two numbers?
Ma'am, it's minus 8 and plus 3.
Very good. It's minus 8 and plus 3. Because minus 8 plus 3 will give us minus 5. And minus 8 into plus 3. When you multiply, you'll get minus 24. Very good. So 4x, split the middle term. We are left with 4x here, write that. And then in the bracket, write the first term as it is. The two numbers are minus 8 and plus 3. So it will be minus 8x plus 3x. And the last term minus 24 as it is. Divided by x minus 8. Now see, you cannot cancel this 4 and 8 because 8 is x minus 8. Between x and 8 is a minus sign. So you cannot cancel. 4 and 8 you cannot cancel. 4x. Then between the first two terms, x is common. So x minus 8. Between the third and the fourth term, 3 is common. 3 into x is 3x. And 3 into minus 8 is minus 24. Divided by x minus 8 as it is. Now 4x. Finish the, finish that one more step we have when we split the middle term. In the brackets, we have x minus 8, write it once, x minus 8, write it once. And then gather the other terms, xn plus 3 in another bracket. Divided by x minus 8. Now x minus 8 gets cancelled. Sorry, I'll write the answer here. So the final answer is 4x into x plus 3. 4x into, see, this one and this one gets cancelled. X minus 8 gets cancelled. This x minus 8 is the denominator here, children. Don't get confused. This x minus 8 is the denominator for the earlier step. Yeah, so after cancelling x minus 8 in the numerator and denominator, we are left with 4x into x plus 3 in the numerator, which is the final answer. Write down, children. Done, children? Okay. Is it over? I didn't get any response. Is it over, children?
Yes, ma'am.
Okay. All right. So again, in the numerator, you can see that in the expression in the bracket 3z square minus 24z plus 48, among the numbers 3, 24 and 48, 3 is the HCF. So we'll have to bring out 3. 3 is the HCF of the 3 terms there. So write 8yz into 3 is common. So 3 into z square is 3z square minus 3 into minus 8z is minus 24z and 3 into 16 is 48. So plus 16 divided by 2y into z minus 4. 3, 24 and 48 have 3 in common. So you'll have to bring out the common factor. That's a very important step. When you have an expression and all the terms of the expression have HCF other than 1. See, 1 is always a HCF of 2 or more terms. But other than 1, if something else is common, you should bring out that common factor. That's the first step. Now, when you again look at the 3 terms in the bracket, it's of the form a square minus 2ab plus b square. Okay, so see here, it should be written as, see here, a the whole square plus b the whole square minus 2 into a into b. I'll write it again for you. I'll just write that again for you. See, 8yz as it is into 3 as it is. Open and close square brackets. The first term is a square. The last term is b square. And in the middle we have minus 2 into a into b. Now, this is z. This is 4. 4 square is 16. 2 into a into b. 2 into a is z. Into b is 4. And you can see 4 into 2, 8, 8z. That's what we have here. So the expression after taking out 3 common is of the form a square minus 2ab plus b square divided by 2y into z minus 4. Now you can, okay, I forgot to cancel here now. I just didn't notice that, I'm sorry. You can cancel y and y here, children. I'm sorry, I didn't notice it. And then this 2 1s are 2 4s are. You don't have to carry it all the way like this. So you'll be left with only this. You'll be left with 4z in the numerator. 4, not wrong. Yeah, 4z into 3 and this one. 2y gets cancelled, so it's 1. Yeah. So now you can multiply. 4 into 3 is 12, 12z. Okay, and in the bracket we have a square minus 2ab plus b square, which is nothing but, what is a square minus 2ab plus b square? What is a square minus 2ab plus b square, children?
Z square minus 2 into 3. 2 into x into 4.
No. Complete the identity, children. What is a square minus 2ab plus b square?
Ma'am, a minus b the whole square.
A minus b the whole square. A minus b the whole square. So what is a here? What is a here? Z. And what is b? 4.
4.
A minus b the whole square. Because the numerator is in the form a square minus 2ab plus b square, it should be written as a minus b the whole square. That's the identity. a square minus 2ab plus b square. If an expression looks like this, a square minus 2ab plus b square, it should be written as a minus b the whole square. So it is z minus 4 the whole square divided by z minus 4. So you can further write the numerator as 12z into z minus 4 the whole square can be written as z minus 4 into z minus 4. Write it 2 times. Z minus 4 the whole square can be written as z minus 4 into z minus 4 divided by z minus 4. So z minus 4 gets cancelled and the answer is 12z into z minus 4. This is the final answer. 12z into z minus 4. Yeah, please take down, children. Please take down the answer, children.
Ma'am,
Yeah.
ma'am, actually I worked it out by splitting the middle term and I got the same answer.
Yeah. You can also split the middle term and get the same answer. You're right.
Yes, ma'am.
Was it Lakshana?
Yes, ma'am.
Yeah, but the thing is, we should be able to identify. See, wherever you can use a square minus 2ab plus b square or a square plus 2ab plus b square, you can always split the middle term and get the same answer. But you should be able to identify where you can also use the identity. That is, you can always get it by splitting the middle term. But if you can use the identity a square minus 2ab plus b square or the other one a square plus 2ab plus b square, you should try to use that. It's not wrong. What you've done is not wrong. But when possible, you should identify this one and do it like this.
Yes, ma'am.
Yeah. All right. Next one. So in the numerator, we have two terms. So how do you factorize it? By taking out the common factor. What's the common factor? What's the HCF of 12 and 8? What's the HCF of 12 and 8?
8.
No. What is the HCF of 12 and 8? 4. X cubed and x squared. The least power is common. The least power will be the HCF. X squared. Y squared and y squared. Y squared. Z and z squared. Z. So in the bracket, we'll have 4 3s are 12. X squared into x is x cubed. That's it. Y square z we already have. Plus 4 2s are 8. And z. Because we have x squared, y square outside the bracket. So z into z is z squared. Divided by 3x plus 2z. Now, the expressions get cancelled. And the result is done, children. Okay, let's just recall long division.
Ma'am, can you show the slide for a minute?
Yeah.
Yes.
Yeah. We'll just recall long division. Okay, so divide x to the power 4 minus y to the power 4 by x minus y using long division. Using long division method. And find the quotient and remainder. All right. Okay. So now x minus y, x to the power 4 minus y to the power 4. So how do you get the first term in the quotient? You need to divide x power 4 by x, which is x cubed. Now we need to multiply x cubed with x minus y. So that will give you x cubed into x is x to the power 4 minus x cubed into y is x cubed y. So first write the first term in the quotient, which is x cubed. And when you multiply x cubed with x minus y, we get x to the power 4 minus x cubed y. Now change the signs. Change the signs. Cancels. X to the power 4 minus x to the power 4 gets cancelled. Now these are unlike terms, so you cannot simplify them. So they'll come down as they are. Write the term which has x first. Write the term which has x first. So write x cubed y first and then minus y to the power 4. They are unlike terms. They cannot be simplified. So they'll come down as they are. The preference is you need to write the term that has x first. Y to the power 4 does not have an x term. The term with x or any power of x will come first because in the divisor we have x first. Because in the divisor, we have x first. Now again, continue. Find the second term in the quotient. X cubed y divided by x. Divide this one by this one. So you get x square y. Now multiply x square y with the divisor x minus y. Multiply x square y. See, first you need to divide x cubed y by x. You get x square y. Now you need to multiply x square y with x minus y, the divisor. That will give you x square into x is x cubed y minus x square y square, because y into y is y square, x square y square. Now write the second term of the quotient, which is plus x square y, and write the terms here. The product you got, write it here. And change the signs. Change the signs. So this one, the terms are the same. They have opposite signs, so gets cancelled. So here they're unlike terms. You cannot simplify them. Write the term that has x first. So x, the new sign is plus. The new sign is plus, so it comes with a plus sign, not minus. And minus y to the power 4. The two terms which are unlike terms cannot be simplified, so they come down as they are. Write the term which has x first. Now continue the division like this. Divide x square y square by the first. So the first term of the new dividend. This is the new dividend. This is the first term of the new dividend. Divide that by the first term of the divisor. We get xy square. Xy square. So that's a third term in the quotient, plus xy square. Now we need to multiply xy square with the divisor x minus y. Xy square into x is x square y square. Xy square into x. X into x is x square, y square. Minus xy square into y is xy cubed. Oh, here, 1 second. X square, y square, I've made some division mistake. Into x minus 1. Okay, no. Okay. Yeah, now write, we have written the third term in the quotient. Now write this product here. X square, y square minus xy cubed. Change the signs. Change the signs. This is square. Change the signs, gets cancelled. Write xy cubed first and then minus y to the power 4. Now divide again, divide xy cubed. Xy cubed divided by x. That will be y cubed. X and x will get cancelled. Divide the first term of the new dividend, xy cubed, by the first term of the divisor. X and x will get cancelled, so y cubed. Now we need to multiply y cubed with the divisor x minus y. Everywhere we are multiplying with the divisor x minus y. So that will give you x into y cubed is xy cubed, xy cubed. And y cubed minus y is minus y to the power 4. X into y cubed is xy cubed minus y cubed into y is y to the power 4. Change the signs. Change the signs. Okay, so this gets cancelled. Y to the power 4 minus, sorry, y minus y to the power 4 plus y to the power 4. See that the terms are the same, but they have opposite signs. minus y to the power 4 plus y to the power 4 cancels 0. So the quotient is x cube plus x squared y plus xy squared, and the remainder is 0. No, I forgot to write the last term, so plus y cubed. Okay, this one. We found the last term, no, of the quotient. This is the last term of the quotient, y cubed. Yeah. So the quotient is x cubed plus x squared y plus xy squared plus y cubed, and the remainder is 0. Is it fine, children? Yeah, online children, please respond. Is it fine?
Yes, ma'am.
Yeah. Since it's time, I've just captured the picture and I'll share the picture on WhatsApp. All right, children? Yeah, now I've sent the picture on WhatsApp. You can complete it later, all right? All right, Yarni, Lakshna, and Shreya. That's it for today's session. Thank you so much. Good night. You may leave the call. Please complete the division, all right, by the next class. Thank you, children. Good night.
Thank you, ma'am.
Thank you.